Yo, yo, what's up, my peeps? Yeah, name's Kempsta, and you've seen me in such fine quality, epic chemistry rap videos such as Measurements Are for Maniacs and Metric System, Metric System. It's all about the metric system. Okay, this is your Chapter 3 review for those of you who are in regular chemistry. And you got a test coming like, tomorrow and stuff. Mr. Canu, I have no idea because there's like a lot of calculations on the test tomorrow. Yeah, you're right. There are calculations on the test tomorrow, and that would be kind of important for us to see where in the world do you start to study? Have you studied? Well, the idea behind this video, it takes place of a bunch of review questions that I would post up. I will show this to class, but I will also put that up on YouTube for tonight, and after that I'm going to take it down. Okay? So, I'm looking, I've got the actual exam here. Oh gosh. Okay. So what does it look like? Well, tomorrow it's the 13th, as you know, and I have got about, I think, 19 questions for you guys. So, what are some things that you would want to know about? What would be useful? As I'm looking at the test, well, one, you're going to see the letters SI. SI, well, think metric. SI is short for System International. Now, this is probably a great opportunity for people to go and actually take out a sheet of paper and write some notes, because you know, that probably will help you out a lot. If you sit there and you're like, then that probably tells me you may not be doing as well on tomorrow's test, unlike those people who are trying to pay attention. So, listen up. So, when we look at the SI, the metric system, okay, we have to look at something called basic units. Okay? So basic units, what about those? Well, what do we mean by basic units? Well, let's take a look at length, okay? We have the millimeter, the centimeter, and the kilometer, right? Well, what would be the basic unit in the metric system for length? Well, let's look at the words. Kilometer, centimeter, millimeter. Well, what would be our basic unit? Well, hey, it's the meter, okay? So the meter is your basic unit of length in the metric system. Now, what about time? That's a little bit tougher. Time, well, let's see, we've got millennia, we've got centuries, we've got days and weeks and months and hours and minutes and seconds. What would really be our basic unit of time here? Well, I'm going to sit there and I'm going to say I probably would go with the seconds. That probably would be it. Okay? Okay, so as we're moving on here, what about volume? How about the basic volume for the metric system? What would that look like? Well, what volumes do we have in the metric system? We have the milliliter, the centiliter, kiloliter, that's kind of huge. But we also have the liter. So when you're looking at the metric systems, I mean, sit there, you look at the liter, okay, so when you're looking at the metric system, you do not pay attention to those first parts of the word. That would be kind of important, okay? You don't pay attention whether it's a killi or milli or centi. Killi, milli, or centi, look at the second half of the word. That's going to be your basic unit. That's the trick, ladies and gentlemen. Okay? All right. Now, let's see. What else do I have to worry about? Oh, yeah. Hey, making conversions. You know, I'm sitting there and I'm thinking, you know, if you're going to be making conversions, let's say from centimeters to meters. Okay? If I've got 1 centimeter equals how many meters? Well, wait a minute. Here's the question you got to ask yourself. What is larger, 1 centimeter or 1 meter? Now remember, the meter is your basic unit, okay? So when you have milli, centi, those are smaller units. They'll always be smaller, okay? So when we look at how many centimeters are in a meter, well, how many cents are there to the American dollar? A cent being 1 penny. Well, there's 100. So when we look at it, it's 1/100th or 0.01 meters. That's how much a centimeter is. Again, that would be useful to know some conversions here. I'm not trying any tricks on you. I will look at centimeter, millimeter, and kilometer. That's it. Centi, milli, and kilo. Those are the basic ones that I want you to know. You should know them. A millimeter is equal to 0.001 of a meter, or 1/1000th of a meter. So I did that in decimal and fractional. So if I were to go and ask a question like, hey, this guy has got a 5 centimeter long stick, how many meters is it? Well, you know it's going to be less than 1. And that's when we have to do our little bridge annotations, okay? You guys might remember the bridge annotations. So if I've got a centimeter, if I've got 5 centimeters, and I need to know how many meters I've got, I have to do that bridge annotation, that bridge notation thing, okay? So what am I going to go with? Well, I'm going to go with 1 meter, and how many centimeters on 1 meter? It's going to be 100. Okay? Now, some people might say, well, Mr. Canu, I'm not comfortable with this being a space out. Well, you can always put a 1 there if that makes you feel good, and then you can multiply across, and you may notice, because remember, this is what you're looking for, you notice that the centimeters will cancel each other out. Okay? So now it's 5 times 1 over 100, so that's going to be 5 over 100, and that's going to equal 0.05 meters. Now that would be like on a multiple choice type question where I would give you other choices to look at, because you really need to know what you're doing for this. So this is one example of doing that bridge notation, converting from one thing to another. Okay? So that would be kind of an important thing for you. Let me see, what other things? Absolutely. Density. Oh, yeah, density would be a big one. Okay, so let's take a look at density here for a moment. Well, what is density? Well, if you remember, density is equal to mass over the volume. Okay, now, there's 2 ways to look at the volume. You could look at the density. You could have in grams per milliliter or grams per cubic centimeter. They both are the same. It's just that the cubic centimeter deals with solid objects, like a block of something, or somebody's head, or a marble, things like that. You get the grams per milliliter if we're referring to liquid, like if somebody gave a blood sample, for example, we can go and calculate the density of that person's blood. And that might give us some clues about a few things. Okay? So, you know, I'm sitting there and I'm thinking, if I end up having, let's say I happen to have a cube, and I don't know what that cube is, all right? And let's say I've got it by 1 centimeter, by 2 centimeters, by 1 centimeter. You know what, let's make this a 1. 1 centimeter by 1 centimeter by 1 centimeter cube. Okay. Then I weigh it, and I find that the mass is equal to 1.00 grams. Okay. So, okay, what's our density then? Well, if density is mass over volume, our mass is 1.00 grams over 1. Now remember, we're multiplying the centimeters 3 times, so it's going to be a cubic centimeter, right? Because centimeter times centimeter times centimeter is in fact cubed. It's a cubed centimeter. Okay? So this is what we have here. Okay? Now, so we got 1 gram per cubic centimeter. That's the density. That would be the density of this block. Now, if you guys possibly remember, you might think, hey, this kind of looks like the density of water. You're right. It is. Although normally we would say water is 1 gram per milliliter. Okay? But that would be something useful to know. So I'll probably give you problems like this. I may ask you, hey, if I have a density of, let's say, 8 grams per cubic centimeter, and I happen to have a mass of 4 grams, then what is going to be my volume? Okay? So that would be another thing to look at. Okay, well, how do we go solve that? Well, remember, density is equal to mass over volume. Now, I will give you that formula. I am not giving you the metric conversions, like what's a milli, what's a kilo, what's a centi. You should know that. You should know that. Okay? You should memorize that. So let's get back to density. Density is equal to mass divided by volume. Okay, well, we got the density, right? Correct? We have our 8 is equal to 4 over x. Okay? Solve for x. Okay. Well, what we can do here, we can multiply x by both sides, right? So I'm going to go ahead. I'm just going to show you the algebra steps here. So 8 times x is equal to 4x over x. This is algebra 1. Notice how the x's will cancel each other out. Okay, so now 8x is equal to 4. That's our next step. X is going to equal 0.5. And in this case, we're looking at volume, cubic centimeter. That is a really tiny object. That's smaller than the dice you see in a Monopoly game. Okay? All right, let's see. What other things would I want you guys to worry about? Let's see. Going off camera here. Okay. All right. So let's talk a little bit about accuracy and precision. Okay, then we'll talk a little bit about integrity. Okay. So let's talk about accuracy versus precision. So if I end up having a target, if I'm looking for accuracy and precision, this is where I'm going to have accuracy and precision. So I've got accuracy and precision. Okay? Now, what if my accuracy stinks, but I'm pretty precise with my measurements? I'm precise, I'm not accurate. What if I'm I have accuracy, but no precision whatsoever? It's kind of a misnomer. You're close to the actual value, but the thing is that your measurements are so wide apart, it's kind of hard to tell. On the other side of the coin, if you've got no accuracy, no precision, so there's no accuracy, no precision whatsoever. Okay? All right. Let's move on. Let's look at integrity. what is that about exactly? Well, integrity, we talked about that before. We talked about honesty, right? We talked about honesty in chemistry. We've talked about honesty in reporting your data to the sciences. Okay, that would be integrity. Now, does that have to do with the precision and the accuracy? More about the precision than necessarily the accuracy. So what am I saying? You do an experiment where you're using two pieces of equipment. Okay? Equipment A only measures out to 2 decimal places. Equipment B measures out to 1 decimal place. So when we're making all our calculations, at the end of it all, okay, we want to have it where we take into account the least precise measurement. Because this is more precise, this is more precise than this. Because it's carrying it out to the 1,000th. This is only going to the 10th, so we will report this. This is having integrity. Okay? If we report it to this, and we use this as part of the experiment, that's dishonesty. That is not integrity. Okay. Let's see. I've got a few minutes, and then I got to look at significant figures. Okay. Very quickly, what should you know about significant figures? Okay. Numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 are significant. It's what do we do with the zeros that are not significant. Now here's the thing. Conversion units. You should recognize what a conversion unit is. That's not considered significant. A conversion unit, if I'm repeating it, that's an important idea. 12 inches equals 1 foot is a conversion unit. Okay? But what if I have 1, 2, 3, 4, and I ask you, hey, how many significant digits is that? And somebody would say, it's 4! And other people would say, wait, he's being a trickster here. This is the chem stuff. I'm going to go with 0. And I would sit there and say, if you chose 0, you'd be absolutely right. Why? There's no unit. The moment I attach a unit, now it's significant. Okay, now what about the zeros? What is so up with the zeros? Well, remember, if we got 1,000, it's only 1 significant digit. If we have 1 with a decimal, 1, 2, 3, this is 3 significant digits. Why? Because it's following the decimal place. Okay, if it's 0.003, okay, that's 1 significant digit. If it is 1.003, that makes it 4 significant digits, because when you have zeros in between non-zero digits, guess what? Those zeros became very significant. Okay? So when you're doing your measurements, let's say you're doing calculations, okay, as we extend this about significant figures, okay, well, let's see. If I'm multiplying, I got 1.2 times 2.52 times 3.10. Okay, when I do my multiplication, here's the thing. It's not the number of significant digits. It's how many decimal places when you multiply or divide. So, when I do my answer is going to be, let's say, 42.0. That is a significant number. That's a significant digit. You need to do that. But what about when you're adding? Well, when you're adding, that's when you deal with the smallest number of significant digits. Okay, I am Dikemsta. This is it. This concludes our review for Chapter 3 for regular chemistry. Hard-hitting, tell it to your friends, and don't forget, get a life.